We have all the day, during the break, during lunch, dinner, breakfast, we can discuss, and it's a hot issue and it should have more time. Our next speaker will talk about saving energy in growing room as a critical area for nanotechnology clean room. And actually, I think all my colleagues at Sigma are really interested in this talk for a special issue. Our speaker will be Professor Muhammad Ala Nawawi, and the co-author is Professor Ashraf Al-Mahyawi. The floor is yours. 9 minutes.
Okay, I will take less than 5 minutes. My name is Muhammad Ala Nawawi, teaching assistant at Al-Wan University, Professor Dr. Ashraf Al-Mahyawi, and our mechanical department colleges, Muhammad Abdel Hamid. The paper Saving Energy in Gowning Room as a Critical Area in Nanotechnology Clean Room. This is architecture criteria. By designing the Gowning Room, the first barrier at the clean room, the main factory of the Nanotechnology Research Center. I will give if you want to save energy, you can do it by using one of 3 ways: efficient types of lighting units, or clean power and renewable energies, or perfect architecture design. And I will discuss the perfect architecture design. The research will focus on studying the most important architecture elements in Nanotechnology Research Center in Gowning Room inside the clean room area, as it is the basic control point from in or out of the clean room, and this shows how important to study the Gowning Room, whether by placing devices inside the elements in the Gowning Room, the furniture design to save area. This area dedicates to saving HVAC, sterilizing, and saving the energy of the researchers in the one area, or by order the time of the researchers entering the clean room through the Gowning Room. Research problem. There aren't any references or codes to determine the architecture design principles for the clean room, including the Gowning Room, that will affect positively or negatively on the work in the clean room, especially the sterilized air, on HVAC filter, and I will use the HEPA filter. The other is auto filter, more cost, on the energy consumption. The research importance and objectives working in Nanotechnology Research Center depend on the clean room as an essential element, which may contain fixed units or others. Research methodology relies on studying the elements of the Gowning Room with furniture, air locks, air showers, and bathrooms. Then the researcher will make an ideal design of the Gowning Room with a standard dimension suitable for the clean room. The clean room, the main factory, as I defined before, and the Gowning Room, the first barrier of the clean room, the main factory of Nanotechnology Research Center. I contact with the Terra Universal Products. This is a company in USA, Florida, designed the furniture of the special requirement for clean room, Gowning Room, special cases of cleaning and using. And this is the plan showing the furniture by numbering these steps, entering from here and air showers, and going to the components of cleaning the researcher after, before entering the clean room, and when the final check go to the by clean room. This is the Terra Universal product, showing 128 meter square. This is too much. That's my design, 57 meter square. Starting here, all the elements, all the components, and I will discuss it in details. This is the pre-gowning, showing secure lockers for closing, and this is all dimension in details, standard and contacting with the products. Show cleaner, air locks with HEPA filter, and this is station 1, hand washing station, hand dryer, dispensers and clothing. This is all the equipped stations containing the furniture standardization. Okay, conclusion, the redesign of gowning room adapted by the researcher with an ideal furniture is 75 meters square from 128 for 75 meters square for each 300, 150 or 60, 100 or 70, 150 meters square modular clean room. One gowning room, 75 meters square, contain this ratio 1/4, 1/6, 1/8, 1/10, more than 750 meters square. There are 2 gowning rooms for 1 clean room. The suitable design module for the gowning room is 0.6 meter in order to put the furniture in the right place with one-way circulation for 5 stations as an ideal minimum area for gowning room. This is very important, assumed by the researcher, as the 2 researchers take 16 minutes for using each one furniture, for washing, for clothing, and so on. From the beginning of the gowning room to enter clean room, I put out the timing for each researchers using the one furniture for each others. And as we see, for the stage 1 take 2 minutes, stage 2 2 minutes, 3, 4 minutes, and so on. We need 10 researchers for 75 meters square. Enter the gowning room, 5 couple. Every 2 will enter the clean room. From the gowning room we have 5 stations, so after 40 minutes the second couple of researchers will enter the gowning room, and so on, 60 plus 60, 32 minutes. This is called overlap timing management for saving energy. 1 by 1, 2 couples. Number 2, on the other side, if there is no overlap in time to enter the researcher in the clean room, the 10 researcher will take 80 minutes. And this is low, this is liquid and low and in energy. To save energy, we use the overlap time management. The last. This is the code of the clean room containing the gowning room, the first barrier. I use, okay, 1 minute. I use the class 100 equal ISO 5 in federal standard, and as we see, air changes 300 and 480. HEPA filter, I use it. CFM, as we see in details at the paper, and generic cost estimate 450, 60, 150 dollar per square feet. I use it plus 100. This is another important conclusion. For 5 meters square, 870 square feet, surface area of the redesign of gowning room adapted by the researchers required 133 ton tabrid. Is refrigeration is required, nearly equal to 200 kilowatt per hour, and this is the kilo hour yearly. Assume cost 450 dollar per square feet, costing $336,000. And the Terra Universal product 122 the other side meter square required 228 refrigeration is required, nearly equal to 342 kilowatt per hour, and this is yearly. Assume cost 400, okay, contain 60,080, 1.5 kilowatt per hour. This is for conservation. And the last, saving energy about, the last statement, saving energy about 148 kilowatts per hour, and saving cost about $2,065.
Okay, thank you, Dr. Muhammad. You promised to make it 5 minutes, but you made it 10 minutes at the root
Okay,
and 10 seconds.
Sorry.
Actually, no, we need to talk about this issue for long, and as far as we have a key room at Simardai, you might make some validation for your results with us.
Okay.
Our next speaker is Dr. Khadija Mahmoud.